Hi, everyone. I'm Lauren Weston. I'm gonna stand here, and I think I can see, nope. I'm gonna stand here, and Charles, you can decide where you want to stand after. If you can't see me, I imagine Charles will actually also stand here after, so feel free to move chairs, rotate, stand up, do whatever you need to do. I'm Lauren Weston. I'm the district manager with the Franklin County Natural Resources Conservation District. Thank you all for being here today and making the trek. Hope everyone's travels were safe in the cold weather that has decided to come today. We are at the Vermont Youth Conservation Corps barn. There are restrooms on all 3 floors, so please feel free to take care of yourselves. There's going to be coffee refills all day and tea. There's snacks. There's hand warmers. If you didn't see them, please feel free to use those. I bought 3 different brands and honestly would love to know which one's the best. So we'll do a little science experiment with that today. We're all very grateful that you're here. And one other comment, we do have a videographer here today and we'll be taking photos. If you are uncomfortable having your video taken or your photo taken, please find me this morning and I will pass that off to the videographer. We're hoping to be able to use this as a training tool for the folks who are not here today as well. We appreciate those who stayed away if they were sick and understand that Richmond isn't necessarily central to the state, but thank you all for coming. First and foremost, want to thank our funders for creating this opportunity for us. So thanks to the Lake Champlain Basin Program and NUEPIC. They were very generous with their funding for this event. I'm very grateful that you all can be here and learn together and get all the resources that we need. So thank you to LCDP and NUEPIC. I also want to thank our advisory group members, and I am going to make you stand up if you're in the advisory group. If you would just stand up and wave. These are some of the experts in our region who have been helping to inform this training program, and they'll be leading many of the stations and efforts today. I did also want to grab I'm not going to make you all do introductions, but we do have some really incredible groups that are here today and just wanted to give them a little shout out. If your group is not represented on this list I'm about to say, that means you also didn't get a book. So if you don't hear me call your organization, please go up and grab a book from Mel and Dorothy. So we've got the Northwest Regional Planning Commission, Friends of Northern Lake Champlain, Lamoille County Conservation District, Franklin Watershed Committee, Champlain Valley Farmer Coalition, the Rural Coalition, Essex County Soil and Water, NOFA Vermont, the Equilibrium, Agency of Ag, the Poultney Meadowy Conservation District, Audubon Vermont, Grand Isle Conservation District, Montpelier Tree Board, the Essex County NRCD, Regenerate Climate, Citizens Climate Lobby, and the Missisquoi River Basin Association. If I didn't say your organization, please make sure that you get a book after this morning session. This is our plan for today. We're obviously going to be a little bit flexible as weather and things evolve. Thank you all for being here on time and for filling out the baseline knowledge survey. Again, if you haven't yet, please return it to the box in the back corner. We really do want to be gathering where people are learning things, where people have questions throughout this entire process. So that's just one step. Once I'm done talking, Charles will give a presentation in here where it's warm. And then we'll head out outside, do some soil exploration, come back in and get a presentation on organic matter, then have lunch. And then after lunch, have 4 different stations where you get to learn different things, and then a group reflection and another evaluation. So I just really wanted to ground us in why we're here. I think if you look around the room, you can see there is a need for soil health education in Vermont, and also to build this community. And so we originally came up with this idea. Actually, I want to give full credit to Katie Janarski, who used to work for the Franklin County NRCD. Her and I dreamed this up several years ago. the folks that we find ourselves working with all have different, really diverse backgrounds and varying levels of knowledge, and we're not all on the same page. We know that there are different messages being told to land stewards. When I say land stewards, I mean farmers, forest owners, loggers, residential owners, everybody who takes care of the land. I think we all felt a bit of a need to be better prepared for when we're going to the field. It's a bit jarring to go out, especially as a young person, onto someone's farm and try to tell them or to assist them in various ways. And also just wanting to make sure that we're communicating the nuances of soil health. There is no one size fits all, and really trying to make sure everyone understands all of the variations. So lofty goals. For this whole course, what we're really hoping to get and create is a collective learning space. I stole Kat Buxton's improved social mycelium. So if you can visualize that, just you being here today is already helping connect organizations and resources to each other. We want to make sure you are as prepared and confident as you can be out in the field. We want to make sure as a community, we are providing consistent messaging that is with the latest science. We also want to use this whole experience as a training tool for those who will come after us. So what we're doing here today is not just for us, it's for everybody else who comes after us. We do plan on updating the science changes, for the record. And we also have to make sure that what we're saying to people is being implemented well on the landscape for improved landscape outcomes. So our offering to you is this course, which includes today an in-person workshop. I know there's a lot of words on the page. And then 12 webinars on Tuesdays from 2 to 4 p.m. throughout the winter. We did cancel some for holidays, so just pay attention to dates. You should have all received calendar invites from me. If you did not, that means I don't think you're registered. So come find me after. We are structuring the webinars with readings that we would hope and ask you to do before each class. And those are capturing some of the more universal themes that we think people should know about. And then during the actual webinars, we're going to dive into the on-the-ground context in Vermont. So it's really important for you to come prepared so that things make sense in the webinars. And that the main text that we're using is the textbook over there. If you didn't get one, let me know. It is also available online. We've got an awesome lineup with a couple still pending invitations, but we've got an awesome lineup planned for the webinars to cover a wide range of topics. And then we're going to have 4 workshops in 2024 in different parts of the state on different landscapes to really apply what we're learning on the ground in Vermont. And we are going to tailor those based on the conversations that we're having in each of the webinars. So please, constant feedback is very welcome. This is for us. So if you're not getting what you thought you were getting out of this, please tell us. We will make changes. And then, so that was our offerings, and here's our expectations of you. Engage, connect, really talk to each other, think deeply, all the good stuff, and practice what we're doing. So don't just let it come into your brain and go out. Really try to apply it on the ground and in your work. And again, thank you for helping us build a training program for the people who will come after us. And you rock. All right, with that, I'll hand it over to Charles. And if you need anything at any point throughout the day, please just come find me. Can't miss.
Thank you, Lauren. And yeah, no kidding. Big shout out to Lauren and Katie Dynarski. They had a vision for this like 2-3 years ago and made all this together. So thank you so much for that. Yeah. Well deserved. So I'm so glad y'all can make it. My name is Charles Williamson. I'm originally from South Carolina. So in this course, I'm going to be learning with you about Vermont soils. I'm going to be asking a lot of questions along there with you. I'm going to be asking a lot of questions that may seem like dumb questions, but like, why does the soil act that way? Anyways, so I really hope that I can be an example of asking questions and helping out with that. So I work as a project coordinator for the Franklin County Natural Resources Conservation District, and I will be presenting for about the next half hour or so. Like Lauren said, bathrooms out through that door on each floor. If you get cold, which I kind of am already, stand up, it's not going to disturb me. Walk around the room a little bit. That's fine with me. Okay. All right. So we're going to talk a little bit about what we're going to cover today. And voila, skip too far ahead. There we go. This one. So we're going to be talking about a few very key concepts about just what are soils, so we can all just like start with the very basics. What is the formation factors? What is the soil health? How do we define that here when we work with land stewards? Key soil properties and soil health indicators. So let's get going. Let's start with this definition. Soil is a natural body of mineral and organic matter at the Earth's surface. And it is a zone where chemical, physical, and biological processes all interact. So soils perform many critical ecosystem services, including water storage, nutrient cycling and retention, water filtration, carbon storage, and supporting biodiversity. So carbon storage, carbon sequestration, that occurs when soils have an input of forms of carbon that are larger than their output. So they start accumulating more carbon. Soils are generally about 50% mineral and organic matter, or the particle matter that you can see and touch and tell what different colors it is. We'll talk briefly about those physical particles, where they come from, and the rest of the soil is space. We call that space in between the soil particles and within the particles, the pores, and that's where it is filled with either water or air. So looking at the physical matter in the soil, we're going to look at, that's about 95% physical matter. And then there's organic matter. That's about 5% of that physical matter. The mineral particles were originally part of a bedrock somewhere on Earth. Minerals can come from direct weathering of bedrock, or they can be transported. And the weathering, what I mean by that is weathering of bedrock means like the breakdown of once solid entities due to a chemical or physical or even a biological reaction or interaction. And glaciers, wind, water, and gravity all move those particles around and as they interact with each other. So the organic matter, that comes from plants, soil organisms like bacteria, fungi, microarthropods, nematodes, and earthworms. And so these organisms live, die, all in the soil. This material decomposes, and some of it's preserved in the soil over a long time and provides really essential functions. So that's how we kind of define those facts. So looking really briefly at some of these, how we measure these physical particles, this was a great slide first shown to me by Abby. Thank you, Abby, for this. This really looks at the differences between sand, silt, and clay. Not only in terms of size, sand is about 100 times larger than clay, which is, if you see on the right, it's like a coin. It also talks a little bit about how they are very differently shaped, and also therefore how they interact with different components within the soil. Okay, and yeah, I'm just gonna next slide. So these soils with all those particles, those physical properties, just within those are very dynamic and they change throughout time. This slide shows the long process of how soils develop over that time. As soils age, the soil particles start to aggregate, as in they start to clump or form together in different manners and form very distinct structures. And the physical, biological, and chemical properties of the soils there, that soil, start to form. As this development proceeds over time, the soils develop very distinct horizons across their entire profile. The O horizon is mostly organic material, partially decomposed plant material. The A layer is mostly minerals from parent materials from below and the organic matter incorporated. The E layers, this is really particular to soils found that are similar in Vermont, like a Tunbridge soil that we're going to talk about later. E layers are found as a concentration of sand and silt particle of quartz and durable materials like silica, found in older soils and in forested soils. And we're going to talk a little bit later about how those form, specifically in Vermont. The B horizon are rich in minerals that have leached downward from the A and the E horizon. And the C horizon is a deposit at the Earth's surface, key in forming soils. The bedrock is, of course, a rock that's such as granite, quartzite, basalt, limestone, or sandstone that are solid forms, and they are not considered part of a soil solution, but it's kind of like a precursor to weathering. Next, we'll talk about how these different physical, biological, chemical processes have an impact on these changes. So this is our soil forming factor equation. You have climate, organisms, relief or steepness, parent material, and time. So these different processes are additions, losses, transformations, and transport. They don't act on soil in the same way everywhere around the world. It's very different. We know that this because soils took a really different, kind of spin, even just like close next to each other. The concept of these soil forming factors offers a way to think about where these differences come from. So the soil scientist V.V. Dokuchev and later Hans Jenny came up with these formations and these soil forming factors in order to explain the differences they saw in soil experiencing different conditions. This equation shows that the state of a soil is a function of these 5 different factors. Now we call these, because that's the state in which the soil is in, we call these state factors, and they are climate, organisms, parent material, relief or topography, and time. And so while that's not an official state factor, because we're looking at human management often in our positions, I would say that human land management has an incredible influence on the soil that cannot be overlooked. So we'll talk about that as well. Okay, so this first state factor is climate. Climate is important because soils weather faster in warmer, wetter climates where that's more energy available for chemical reactions and more water to transport the ions that cause these chemical reactions from one spot to the next. Warm, wet conditions also support plant growth, which can increase the inputs of organic matter. And I lost my place. Sorry about that. Cold conditions can make decomposition go more slowly, so you end up with more organic accumulation, which is important to the development of organic soils like those found in wetlands. The diagram on this slide shows how climate can influence soil development. Overall, we expect to see the most soil development in warm, wet conditions. By development, I mean change. That's decomposition, that's accumulation, that's everything. Here in Vermont, we tend to have more of cold and wet conditions, like today. We have really conducive to organic matter accumulation, which is explained why we have a high amount of organic matter typically found in Vermont soils. So the next state factor is organisms. These organisms matter because organisms are where organic matter really comes from. Typically, the more plants that are growing, the more organic matter there is in the soil. Plant roots and the depth of rooting can also determine the depth of organic matter accumulation. Plant roots are absolutely essential for soil development as they form interactions with many of the microbes, like sorry if I can't see, you can't see it, the soil. We tend to see the deepest, richest soils in native grasslands and prairies where roots are extremely deep. The respiration of soil organisms also produce carbon dioxide, which dissolves into water to make carbonic acid, and that participates in mineral weathering. So the actual exhaling respiration of these organisms contribute to a chemical weathering as well. The acidic solution can then break apart complex organic compounds. So the presence of an active soil biology is also going to contribute to soil weathering and development. The diagram on this screen really shows you the different soil horizons and the depth of organic matter accumulation in different ecosystems based on that biology. I want to call your attention to the rightmost image showing a forest, because this is what we're talking earlier about an E horizon. We have a lot of forest in Vermont, or even areas that used to have forests. Forests produced foliage, especially here in Vermont, that were pretty acidic. And when the trees drop their needles and they decompose on the forest floor, these organic acids, they build up on the surface horizon. And these organic acids essentially act as a claw and attach to the iron and aluminum at the surface soils. The whole organic matter metal complex is then transported downward into the soil solution. And this gives rise to a whitish E horizon where the humus, the iron, and the aluminum all have been lost. These compounds all accumulate lower down in the subsurface, so we really get a dark B horizon below the E horizon with lots of accumulation of iron, aluminum, and organic matter. And so soils where this process happens are called spodosoils, and they are one of the more common soil types here in Vermont. Spodosols is also a soil order as well. So the next state factor is landscape, relief, or topography. The relief influences just a large amount of processes, including additions, losses, and transformations. So the steep slopes tend to erode very quickly, causing a loss of material and resetting the clock on the soil development. Remember that time is also a factor. So slope therefore influences, depending on what's going on, a whole nother factor that's happening in time. The relief also feeds back to affect climate. South-facing slopes tend to be warmer and drier in the northern hemisphere, which is going to affect biology and weathering as well. So the hill slope model right here can be a helpful concept for understanding how relief influences soil across a landscape. The curve represents a cross-section across the hill. At the summit where it's flat, the soil doesn't erode very much. The soils on the shoulder slopes and the back slopes, the kind of convex part, tend to get eroded heavily, and so the soils will be thinner. Soils at the foot slopes and the toe slopes, kind of in the flat areas, receive these eroded materials in our zones of deposition. All right, so if you can imagine, this model would also affect water drainage. Looking at the slope, some things to think about. Do you think that the shoulder slope or the toe slope would have better water filtration?
Sure.
Yeah, something to think about. And we're gonna go break into groups, and I want to hear discussion about that. That would be really great. All right, this next factor is called parent material. This parent material matters because different types of rocks have different textures, as well as different chemical compositions and minerals, which will affect the mineral weathering and therefore the soils that then form afterwards. The diagram on the right shows the range in the grain size, as in the particle size and the chemical composition of some major types of minerals found in soils. In terms of the chemical composition, when you're thinking about felsic or salic minerals that have more silica and aluminum, they tend to be more acidic than mafic minerals, which tend to have more magnesium and iron, and tend to be more basic in the mafic materials as opposed to the felsic. It's more acidic. Different minerals also differ in how weatherable they are, as in how long or how impactful the time state factor can be. Felsic minerals are typically more resistant to weathering than mafic minerals. And then minerals also have different textures, which will further influencing the weathering rates. So like fine grained minerals tend to weather more rapidly due to their higher surface area. And parent material can also be material that's been deposited on a landscape, such as river settlements or glacial till. And these deposited materials can then have different textures, chemical composition, will then affect the soil's form. It is cold. For real, if y'all need to stand up and like wiggle your arms around a little bit, I totally get it. All right, so we're moving along. The last official state factor I've been talking a bit about is time. Time is that secret sauce that integrates all other state factors, all the processes we talked about before. So over time, soils develop, the biology of the ecosystem changes, weathering happens, chemical transformations take place, and soils may receive new deposits of parent materials or experiencing erosion, flooding, all those disturbances. You may think soils currently on Earth may be the same age, but they're not. Glaciation is one of the major geological events that has influenced the soil age all over the world. The movement of glaciers across the Earth's surface scraped. I'm just doing this for scraping, I swear. It's not because I'm cold or anything, it's fine. Removing all the soils and depositing new materials. So you can really think of, the glaciers just really pushing and disturbing all that topsoil, resetting that clock every time they go through, and also depositing different materials there. Soils in areas that have never been glaciated, such as the tropics, are much older in soils that have been previously glaciated. Here in Vermont, the last glaciers receded about 13,000 years ago, so essentially none of our soils are older than that. Deposited glacial till comes in many forms. It can range from large boulders to crushed sand. One type of till is called a hard pan, found frequently in Vermont. It's typically of smaller particles of sand, silt, and angular pebbles. And it can be really difficult to separate, even with a pick and a shovel, due to its compacted, because it had the weight of an entire glacier compacting it down. And so it forms a very dense layer. So deposited glacial till comes in many different forms. It can be large boulders, or it can be a compacted, hard pan like that. Additionally, the inputs of new materials from deposition or the loss of material via erosion or flooding can reset soil development. So many of our soils in Vermont are younger than 13,000 old because of deposition and erosion. And just like some breaking apart things too. Okay. All right. So, and lastly, I want to talk about the human factor. And I think that's really helpful to know a little bit about the agricultural history in Vermont, because that's definitely been influence on our soils. And as well as, the soil has influenced the human activity, and the human activity has gone right back and influenced our soil. That's pretty interesting. It's very much a back and forth. We're going to jump back to the end of the glaciation about 13,000 years ago. So this is a picture of some of the glacial lakes that were present here in Vermont. You of course have Lake Champlain, that was the Champlain Sea, but also you had these large lakes going inland as well. So Vermont has been an Abenaki homeland since time immemorial, and evidence of settlement on the shores of what we call Lake Champlain date back to at least 13,000 years ago. So basically, as soon as the glaciers receded, the lakes were center of trades between nations, and the Abenaki people were engaged in numerous agricultural activities, maple sugaring, hunting, and fishing. Some of these key crops that they also did in agriculture were corn, beans, squash, sunflower, Jerusalem artichoke, ground cherry, and tobacco. It's worth noting that the Abenaki language includes many different words for classifying soils, indicating a very nuanced and detailed understanding of soil science. If y'all want to know more about some of the Abenaki, foods, agricultural thing, you can talk to, where did Mel go? Mel there in the corner was, recently attended a lot of great trainings on that. Okay. Moving on through the freezer, colonization hit Vermont in the 1600s. In 1609, Samuel du Champlain came across Vermont, guided by Alcuin guides, and claimed northern Vermont for France. This set off a period of both French and British colonization all across the state, in which wars, genocide were waged on the Abenaki people. Colonists established small farms throughout the state and were mostly engaged in subsistence farming. The agricultural scene really remained subsistence for a very long time and began to scale up around 1790 when the establishment of shipping routes made large-scale export of agricultural possible, and colonizers began clear forests on a just very large scale across Vermont to export all of their potash and pearl ash that they got from burning all of the wood that they cleared. They also produced potatoes, grains, and beef cattle for export. This set off a period of widespread deforestation in Vermont, and by 1800s, 80% of Vermont had been totally cleared of its trees. My understanding that most land below 2,500 feet in elevation were cleared during this time. This clearing happened because most of the demand for forest products and also the cleared forest could be used for pastures. And this became especially important during the 1830s and the 1840s when the price of merino wool was very high and the Vermont settlers were raising sheep in a massive scale in merino wool craze. The craze did not last forever, and by the late 1800s, the price of wool dropped and Vermont's wool industry collapsed. Vermont farmers switched to dairy and got into producing butter and cheese, as well as maple sugaring, hops, livestock, diversified products and produce, and lumber in the 1890s. In the 1890s, Franklin County Creamery Association in St. Albans was the largest butter factory in the world. Also, a quick note, from 1830s to 1850s is when almost all of the stone walls in New England were built. It was during that craze, during that time. And when you think about how many stone walls are out there, delineating parties, outdoors and everything, they were built in about a 3 to 4 year range, which is a massive effort. Okay. So throughout the 1800s, we're going to talk a little bit about how humans influenced the landscape here. People started thinking that maybe deforesting the state wasn't so great. In 1909, Vermont appointed its first state forester, which marked the official beginning of attempts to reforest the state. All the while, dairy continued to grow in Vermont, particularly where refrigerated train cars allowed shipping liquid up, and it didn't need to process and butter cheese in order to sold. Again, modernizing to add tractors, new machines, bulk tanks, and with this new and often expensive, technology, smaller farms began to shut down while other farms just expanded. This is a trend we essentially see continuing today, and it's interesting to note that the number of dairy farms in Vermont have been declining since the 1880s. The 1900s is also when tile drainage became widely used. Now, if you're not familiar with tile drainage, I found this really helpful picture. So above, that's an example of, kind of a saturated field and an example of what a farmer would be trying to deal with. But below you can see they installed the tile drainage. It's got perforated pipes on top. It's got holes on top that allows the water to seep through, and then the pipes remove the water from the field. So this major installation hugely impacts and modifies the Vermont hydrology all across the state, wherever it's put in. So today, dairy is still one of Vermont's major agricultural products, and it's still one of the main crops in the area are all associated with dairy, including forages, silage corn, grain corn, And it's an interesting statistic that I saw is that 80% of open land in Vermont is associated with dairy farms. So it's an agricultural product that is still very much shaping our landscape and therefore the soils beneath. Since the merino wool craze, a lot of Vermont's forests have regenerated, and now 80% of Vermont's land is forested. And Vermont also leads the country in maple products that, also has its root in the deforestation craze. When the forests were cleared in the 1800s, the soils warmed up enough to really favor maple trees when those forests regenerated, giving us a slightly different forest composition than before. Maple is also a first successional tree. This is one of the ways that human actions has influenced soils and the ecosystems supported by forest soils. All right. So this is an example of our state soil, state coverage. You can clearly see that E layer and then that stark contrast to the B layer underneath. So to wrap things up for talking about state factors, I want to talk about the land use history, particular, and the state factors we discuss and make note of how these different factors show up in Vermont and influence the soils that we have here. So in terms of climate, we got a cool, wet climate that limits decomposition, making Vermont soils excellent at accumulating all this organic material. The cool, wet climate also makes for slower weathering and soil development, and so we have a lot of relatively young soils here. In terms of organisms, Vermont's landscapes was historically forested, leading to many acidic forest soils, even in areas that have been since cleared for pastures. So if you've ever dug a soil sample in the pasture and find a very light E horizon, that's a soil remnant of the forest that was once there. So the organisms within those soils historically had become acidic soil adapted. In terms of slope and relief, we have a lot of mountains and hills and river valleys, and they're pretty prolific throughout the state. So these slopes affect the soil drainage, the thickness of the soil, and the age across all of our landscapes. The parent material in Vermont depends on its location. In areas that were once covered by those glacial lakes, the deposits of ancient water bodies give us a lot higher amount of calcium as well as clay in the clay-rich valleys. Excuse me. This really was common in the Champlain Valley, or as well as in the Connecticut River Valley. And other areas that weren't covered by the ancient seas were covered by glaciers. So the soil parent material typically came from glacial till, the materials that the glaciers were transporting around. And the characteristics of the till effect impact the soil texture and, therefore rockiness. So in terms of time, we're very young soils. The last glaciers were seeded about 13,000 years ago. Because of that young age, many of the soils in Vermont don't show a ton of soil development. Humans, we have changed the Vermont landscape up and down, and soils in some really big ways, particularly in the 1900s. The history of draining wetlands and wet areas dramatically altered the soil hydrology across the state. Farmland is often in areas that was once forested, so it's somewhat typical to find a pasture or hay fields in Vermont with this distinctive forest soil underneath. And something to think about throughout today is, how these soils will develop over the next 100 years. How much of Vermont's cropland is perennial pasture or hay fields. And with good management, these particular crops can bring a lot of organic matter fairly deep into the soil profile, which could influence the soils developing over time. Okay, so that was kind of our background on soils. Now we really need to define going forward, what is a healthy soil? So the USDA NRCS definition is the continued capacity of the soil to function. And I really like emphasizing on those first few words. So the continued capacity is what we really measure a soil is like, what capacity is it functioning at? Is this a healthy soil? Well, what is its capacity to function? And to function, we say, as a vital living ecosystem that can then sustain plants, animals, and humans. Soil health is defined very differently, but generally it's within the realm of, is it quality soil or is it healthy? So let's break that down a little bit further and then think about what functions allow a soil to sustain life. I like this list here. It's of healthy functions from the Cornell Comprehensive Assessment of Soil Health Manual. In this frameworks, healthy soils retain and cycle nutrients that support plant growth, sequester carbon, allow water infiltration, and facilitate water storage and filtration, and suppress pests, diseases, weeds, detoxify harmful chemicals, and support food, feed, fiber, and fuel production. And so that's, really what sustains a vital living ecosystem. That's the capacity that a healthy soil has. So in order to know if a soil is healthy, we get to come back to our soil properties. The soil properties are a toolbox for understanding soil health. Some can be assessed visually out in the field, while others require laboratory assessments. Some key properties of healthy soils include good aggregation and structure with a lack of compaction, sufficient water storage and drainage, sufficient supply of nutrients, but not so much in excess that it can be a pollutant. A large population of beneficial organisms ranging from small insects to bacteria, fungi, and low weed and pathogen pressure. And there are many properties that can tell us something about soil health. Properties that are particularly easy to measure and are sensitive to variations in climate and management can tell us something meaningful changes about soil functions or soil indicators. So we're getting close to the end. I know all freezing and my thumbs are getting a little numb. So soil health indicators. This is broken down into chemical, biological, and these are all broken down into, can you measure them easily? Are they impacted by human factors or seasonal changes? Because in different areas, like I'm from South Carolina, I am going to have a very different list of soil health indicators than what is used to measure soil health up here in Vermont. So this list changes, and it's really important to know that. And, we'll, of course, send the slides so y'all can, look at these and, have this list for you for sure. All right. So when you think about soil health principles, the main thing that you need to think about when assessing whether a soil health is healthy or not is, first you start with your context. Context is everything: the systems, the management, what tools you have, where you are, land history, goals, everything. And then when you go from your context, you go to maximizing your living roots in your soil. Having living roots in your soil, not just having residue on top, really impacts the biodiversity that's going on underneath. Living roots in your soil pump out so much root exodus. They have interactions with so many different other organisms underneath the soil. It's truly a field of its own. It's amazing. Then to make sure that those living roots, you move on to the next one, you have a diversity of those. You have a diversity of animal diversity, can be microanimals, microbiology. It can also mean animals on top of the soil, changing up from different forms of livestock. And how those all kind of starting to look at how you form the landscape. You want to slow down and sink the water. It means like having a hard pan across the surface of your soil really doesn't allow for soil to filtrate down through into the soil. And so having a good water filtration system that also retains some of that moisture is a balance that you need to find. Cover the soil, this means plant cover. This can also be different from the maximizing the living roots in terms of having residue that you leave on top of the soil that doesn't, just decompose immediately. And maybe some harder, tougher things that can cover the soil. And looking at minimal or minimizing your disturbance, that's very, closely tied with, of course, cover the soil. When you're disturbing the soil, it can really expose it and remove that cover of the soil that you have. All right, so just real quick, some main takeaways from these guys. Soil particles are composed of those, mostly of the physical matter, and then like 50%, and then 25% air and water, and then a very small percentage of organic matter. The soil formation is based on those state factors. The soil health is a description of that soil's capacity to function. And yeah, there we go. All right. So, pop quiz. Who can tell me what the first soil health principle was?
Which one?
The soil health principles. Number one was what? Context. Those are soil forming factors. But the context is something I'm going to give you real quick right here. And then we're going to go do our activity. We're going to split into groups. And you're going to use the context to start analyzing soil. All right. So here we are at the BYCC farm. This was acquired back in like 2010, I believe. This barn here was built in 1901. It was the Wheeler farm. It was a dairy farm up until the 1970s. I tried to get information about their pasture management, but I think you're just going to go out there into the soil and make your own decisions. If y'all know Danny Peak or Jenny Bartlett from the NRCS, they know a lot about this farm. All right, so then it was a dairy farm with the Wheeler family till the 1970s, and then the Connetts did corn and soy pretty much throughout the entire thing until 2010. That's when BYCC got it and started doing vegetable production. Also when they became organic. So field up there, number one. All of these fields, so field number 4, field number 1 that they use for vegetable production, certified organic. Number 2, number 3, those are not in the certification process, so take what you want with what that information is. The soil, just looking at some of the physical property, it's a really sloped silt loam that creates gullies really easily whenever it rains. And it's at a completely, this is a little interesting note, completely different soil type on the north side of the road of Route 2, that's going that way, than on the south side of Route 2. And I want y'all to discuss what y'all think those differences are. See, and on those fields, they applied, organic fertilizer, pro-grow of like, NPK ratios of 10-0-0 recently, or in the past, like, that's been their management. And their goal has been to increase organic matter percentage.
That is working with soil health farmer groups. And so we've taken a lot of Cornell soil health tests. And we've been spending a lot of time going through those, trying to figure out what it all means. And one of the, things that we keep talking about are, and you'll see a lot of out here today, like all these different metrics that are used to measure the health of the soil, right? They're indicators of healthiness. So maybe an indicator of healthiness for us is how many times somebody can run around this area before they have to stop. So do we want to demonstrate that varying healthiness? I mean, I think it would help warm people up.
Yeah, Nicole, you want to?
Nicole, I saw Nicole was really into it. So there's so many indicators, and when you get those tests back, it's, you know, they don't always feel like they always make sense, you know? And I don't know how many hours, you guys, have we spent, and I say we show up once in a while, but when I do, I'm like, oh yeah, why is that like? So this wasn't what I was gonna talk about, but I'm gonna just say it now, is that those tests, they're kind of like a soil, you know, it's like taking a soil test, but even more complex. But I think what people really have to remember is that you have to actually know something about the farm and the management and the context. We talked about bringing things, you know, into context a lot, because just looking at some of these, it'll say it's super healthy. But then when you go out there, you're looking at it and you're going, that's healthy. So you have to really dig into these indices and metrics. And you can't just look at that piece of paper. You know, soil health, as we talked about a lot, and that was the point of the exercise, was to go out and make observations. Understand what's going on. The point of having Jake, remember Jake? Talk to you a little bit was to add more context, more information, to help inform your observations and what you were seeing and maybe why. Okay, and then taking some of these tests, and even if we had them, we could start like connecting the dots sometimes. And I think that's really hard, especially for beginners, but maybe even harder for the old farts. Willie, I was going to say myself, but you're sitting right there. Sorry.
Me, but.
Yeah.
Jason,
But, you know, for those of us that think we've seen it all, you know, we can figure it out. You know, it becomes really difficult when things don't start to add up. So the beauty of having a group like this is to be able to work with each other, bounce things off with each other, and just sitting, all of us, I don't know, sometimes there's 4, 5, 6 people all looking at the same thing. Some of the people had been to the farm, some of the people hadn't. There were like little nuances and details that were really critical to actually understanding why those soils were looking the way they were on that test. Okay, so what we have to remember is, it doesn't always make sense. There's not always an easy answer. And just, you know, for everybody else to know that soil health isn't always the answer either to what's happening, maybe negatively on that farm. Okay, and we had a lot of conversations about this where there wasn't really anything about the health of the soil that we could see or we had observed that was limiting the crop production on that farm. That there had to be something else. And sometimes that something else has to do with the landscape, right? And so we observed some of that out here, thanks to Phil, getting us out of our comfort zone, making us walk out into the boondocks. Just understanding, like, sometimes the soils are just really wet. And even with the healthiest conditions, they're still going to be challenged, you know, compared to something that we saw, I don't even know what direction that was, but there where the vegetables are being grown, right? You dig that up, it's like a brick. But I bet it grows damn good vegetables every year. Not very healthy, sorry. So there's a lot to unpack. Okay, so you're going to learn some things here, but we need each other to help continue to understand how to really take all these tools, our observations, and help farms, achieve better soil health. But also realizing it's not the only thing that we need to be observing and looking at. All right, so that was not at all what I was supposed to talk about. Now, which is organic. Here's a bunch of organic matters. Actually, we're all organic matter, right? Last,
Yeah, well, somebody's organic
yeah,
matter.
right?
Well, most of them are.
Okay. And the reason I wanted to talk about this is because the metrics that we're looking at are really often influenced by the types of organic matter that were added to the soil or that are growing on the soil, okay? And they're all really different. So I'm gonna start with things that we could add and what the properties of those are on a very basic level. I didn't do any analysis or anything. And then what they might influence when we're looking at soil health indicators, because it's very, very different, right? So let's start with the first little bit of organic matter. What do you call this? Plant, living, right? Living organic matter. And if everybody read their book, whole thing, start to finish, some of us have probably read it multiple times over our lifetime here. Fred talks about living organic matter. Okay, what are the three types that he classifies organic matter?
Living dead and buried dead.
Right, and it's super basic. And believe me, within those categories, there's about a bazillion other things that people classify organic matter as. And they all have acronyms, which I know everybody loves here, right? Mammal, like a whole bunch of stuff. But if you keep it simple, living, dead, and very dead, it's pretty easy to understand. All right, so this is living organic matter. What else in the soil would be living organic matter? The what? Bugs, all kinds of bugs, right? Microbes, bacteria, fungi, protozoa, moles, worms, okay? That's all the living organisms in the soil, including the plants and the plant roots. The soil food web. There you go. Yep. All right, so one of the things I want you to notice about this that might help you understand some of the indices is that it's green, right? And green for most of us is like living. It's photosynthesizing, right? Maybe not right this moment, but so it takes carbon, right? And sunlight, or it takes sunlight, photosynthesizes and builds, tiny carbon complexes, as well as all kinds of other nutrients, etc., to grow plant biomass. So when you incorporate this into the soil, what happens to it? It breaks down, decomposes, okay, quickly, slowly. Okay, it's,
Sort of.
look at what I'm showing you,
Quick.
quick or slow? Quick, okay, all right, so when we're feeding cattle, I know a lot of you here work with livestock producers, you want high energy, high protein, nutrient dense plants, which is exactly what these are, very vegetative, very leafy, to fuel your animals. The more energy, the faster it moves through a cow. It's no different in the soil. Okay, this has lots of energy. The microbes need the energy. It has lots of nutrients. Microbes need the nutrients. It has soluble carbohydrates. Okay, all the things that will break down really quickly, get eaten up very fast by a certain set of microbes. Okay, a lot of bacteria, some protozoas, worms, things like that. Okay, so this will get used up fast. And this is the kind of organic matter that you would incorporate and expect to get broken down relatively quickly. So if this was incorporated in the spring, relatively quickly is 60 to 70 days, right? Okay, so you're not gonna get 120 pounds of nitrogen within the first few weeks of incorporation. Okay, it does still take time, but it goes relatively quick, right? So the other thing about the living is that it's living and it's breathing. So when you are measuring respiration in the soil as a metric of soil health, what part of the organic matter are you capturing? The living,
Moving.
right? Okay, so we often see respiration relatively high on fields that have cover crops actively growing, or like a perennial forage. So when we take those samples in the spring, we get that analysis back and we see the respiration is higher than if we took those samples from a field that didn't have anything growing. Okay, that would be probably one of the only differences we might see between a field that has been cover cropped with like a cornfield with a cover crop versus a cornfield without one. Everything else could actually look identical. If they've had manure, they were in the same like basic continuous corn, but one has a cover crop and one doesn't. The only thing that you might see that's different is respiration. This is very disappointing, actually, because you, okay, but again, it's showing that there's life and more active living material than in those fields that don't have anything growing. Okay? So respiration is a way to look at it. So the living does a lot of things. And one of the things that it has to do to survive is it needs to eat the dead. This is disgusting. And sometimes the living also eats the living, which is also just, I don't know what's more disgusting. But the living will eat the living often, but decomposition is the living eating the dead. And it's the newly dead, right? So I don't think this is probably something sanitary, but you can't see it that good. I was out this morning finding this cow patty, and because I wanted to show you dead, recently dead. And a cow patty represents recently dead. Okay. And you can see, you can't, it's dark, but we'll pass it around. Sure. I mean, it's been dead for a little while. There aren't many cows here for a little. But and you can see that you can see some of the corn. No, you can't see. You can see some of the plant material in the middle. Okay, so we would say that's recently dead. This is recently dead, right? This is what we would like call crop residues. What's really different about this compared to that, besides the fact that it's dead? Dry. It's brown, right? What has it lost? Moisture, sugar, carbohydrates, sugar, right? Proteins. Okay, when things die, right, those quickly degradable items go away, or they're moved in the case of corn, into the kernel, right? Into its babies, essentially. Okay, so this would also be recently dead. Now, the thing about the recently dead is that it's still yummy to microbes, but different ones, okay? It's brown. And it's already sort of decomposed. right? It's not green, that stuff. Yeah, so it takes different microbes to break that down. Cause there's more what?
Or,
What's left when you have to get all the good stuff, the carbohydrates and the sugars?
cellulose.
Lignin,
Hemicellulose.
Hemicellulose, there's often pectins, okay? Right? So there's still some nutrients in there, but there's a lot of carbonaceous material. And that takes a whole different set of microbes to break down, okay? And it takes longer, it's harder to break it down. So it lasts in the soil for a longer period of time, especially the more lignin, the more cellulose, okay? So that cow manure does have more lignin and cellulose because the cows shit out the stuff that they can't break down in their rumen, correct? Okay, so they're taking all the good stuff out, incorporating it into milk or meat, whatever. And then they shit out the back, the stuff that they couldn't break down themselves. And they've got a whole microbiology in their stomach. So then what comes out the back end of the cow has to be broken down by a whole different set of microbes that can actually get something out of that. Now, we know cows or other livestock don't always need everything that's in the plants either, or what they're fed. So oftentimes we get some other goodies out the back. Okay. So recently dead gets eaten by the living, and they're breaking it down. And through their process, they're exuding glues, they're wasteful, they're kind of making a mess, which is good for the soil. And it's also releasing extra nutrients that they haven't used for your plants, okay? So what happens to the dead once those microbes get at it? Is it gone after that? Probably some of it. But there's still stuff left, right? That's really, really difficult. Actually, probably almost impossible for a microbe to break down. And that is the very dead. Okay, and that's similar, but not exactly similar to like compost, right? Compost was some living materials that then became dead, then underwent microbial transformations through the composting process, right? And then all of a sudden it becomes this whole different material that doesn't really smell like decaying material, right? And it's kind of a different color. It's kind of black, right? Okay, so this is what is it's mostly decomposed. But you can pass this around, but you can immediately see the difference, right, between the cow manure, the living, that this has been decomposed to a whole different level. And people add this to their soil, right? And it's not very, very dead, but it's more dead than cow manure. So what's left here for microbes? Is there still stuff here?
Sure.
Yeah, there's a little bit, right? Different class of microbes can chew on this, get some stuff out of it. Depends how long it's been composted and how actively it's been composted. But it definitely becomes a very different soil amendment, okay? Usually it's like lower in nitrogen, higher in phosphorus, more carbon, it has more charge to it. So it plays a different role in the soils. It really should not, most compost should not be used as the sort of primary fertilizer source. Okay, it's more of a soil amendment, a long-term soil building process is really what you should use compost for. And you do get nutrients out of it over time, right? But it's slower and it depends on the compost. All right, so when you actually extract organic matter out of the soil, like I said, you can get this thing called the light fraction, which we also call active carbon. And on the Cornell soil health test, that's one of the measurements you get back. So active carbon is sort of an indirect measurement of the of the dead. Okay, so it's what's forbidden. Can be actively utilized by the microbes. So it's recently dead. And this is what it looks like. No, that's it. I can't even see. When you extract it out of the soil. And if you fold some of it up, you can see it still looks like plant material. And it's light colored. And this is active carbon or the light fraction. Okay, it's called the light fraction because it's low.
It's a density thing.
It is, and there's a lot, like I said, there's as many ways to remove organic matter from the soil and as many names for it as we could sit around and talk about. Okay, so light fraction, you know, you can float it out of the soil basically, or you can use a chemical test like is used on the Cornell soil health test that measures kind of the same fraction of organic. Okay, and then here's very dead. And this came out of different soils as well. You can see it's black. Okay, and if you looked at it under a microscope, it would just look like dust, black powder, biochar. You know, it would has that sort of color,
Stable
texture,
carbon.
super stable carbon. Okay, unidentifiable carbon complexes. You know, microbes don't recognize them, but it serves a huge function in the soil. Okay, that's what helps create cation exchange capacity, holds on to water, helps create porosity and aggregates in the soil. So it's super important and critical to the function as well, but it does something different. So compost does something very different than cow manure, than cover crops. But they're all critical, okay? All the types and qualities of organic matter are really critical in building a healthy soil. It's not just one or the other, because when we look at all of our research studies, we see that the cover crops pretty heavily influence respiration. When we add manure into the system, we get more aggregation, right? And then when we add something longer term like compost, we get better water holding capacity, as an example. So, and then when you add in no tillage, you get more on top of that. So sometimes we have to take small steps, you know, when we're doing our work out in the field with farmers, but ultimately we need to be thinking about how all of these practices build on each other. They're all doing very different things. And that's why we kind of wanted to talk a bit about, you know, what are these different types of organic matter that we have in our lives? What can we do with them and what do they influence in the soil? And again, it's obviously far more complicated than that, okay? You know, different cover crops have different mycorrhizal associations. They help acidify the soil and release phosphorus. I mean, the opportunities in some ways are endless as you get to know more about all the specifics, right? I mean, it's fascinating to me how you can change the biology of the soil and nutrient cycling just by picking the right crops to grow. Okay, and using compost combined with, you know, more soluble sources of nutrients can make a really productive agricultural system over the long term. So again, it's complex, but if you take it back to the living, the dead, and the very dead, and the living, the dead, and then it becomes very dead, right? It's a process and a cycle. And we're trying to encourage that and making sure all the pieces are there and functioning 100% so that we get the overall benefit. And with that,
Yeah, it is lunch. The folks want to take a half hour. We're gonna start the next thing at 12:30. I'm gonna tell you lunch is over at 12:25.